Alrighty, guys. So we are back to solving log equations, okay? Your homework is numbers 49, 50, 51, and 53 on the following sheet, okay, which has all the, it's on the same page as our previous homework, okay? This is a continuation of our last lesson, okay? This is day 2, solving log equations, all right? I did post on Schoology within the resources folder for log and exponential equations. I worked out all the answers to the homework. So if you're having trouble getting the answers when you go to check them, okay, you can open up that file and it has all the answers for day 6, day 7, and now we're on day 8, okay? So you can check all your answers. Now, there's only 2 questions. They kind of take a little while, all right? As far as what's happening today, one of the focuses is sometimes log equations do not have solutions, okay? Or they have what's called extraneous solutions or extra solutions, okay? And that's because, like, let's say I asked you to evaluate log, right, of negative 100, all right? You did this in IXL, right? We would set this equal to x, and you'd be solving for this in exponential form. So you know the base is 10. So 10 to what power equals negative 100? Well, can an exponent make a number negative, right? If I do 10, right, and I want to make it 100, right, and I make it negative 2, right, because I want the negative there, well, 10 to the negative 2 is really 1 over 10 squared, isn't it? So is it possible to change the sign of your base with an exponent? No, it's not, okay? So here, there is no solution to this, okay? Log base 10 of negative 100, this number here, okay? This can never be negative, okay? If it is, then that means there is no solution. It's an extraneous solution, and we can't solve it, all right? So that's what we're going to be checking for today, all right? Now, if you take a look at this, right, this is log of 10x plus log of x minus 3 equals 2. Now, we're going to use the property of logs here, okay? If you guys remember, if I have addition, okay, I can condense this. Okay, so my first step is I'm going to condense this. Addition turns into, if you remember on IXL, multiplication. So now we're going to have log of 10x times x minus 3 equals 2. Okay, so your first step is you're going to condense. Then our second step is we're going to distribute. Okay, so log of, we're going to distribute the 10x in, so 10x squared minus 30x equals 2. So now we have the log of that expression. Now, if you remember, right, we have a single log. So up here on our homework, our classwork that we did, if you have a single log, you're going to go to exponential form. Now this is going to get a little more complicated, but we're going to do exactly what we did on the previous homework. So the base here is 10, okay? So I'm going to turn this into, I'm going to rewrite it in exponential form. So I'm going to have 10 squared equals 10x squared minus 30x, okay? So that means I'm going to have 100 equals 10x squared minus 30x. Now, if you remember, this is a quadratic equation. So we also, when we went to distance learning, talked about how to factor this stuff and reviewed that. So here, if we have a quadratic equation, what we have to do is it must be equal to 0, okay? So you always want to keep the x squared positive. So you're going to subtract 100. And then you're going to have 0 equals 10x squared minus 30x minus 100, okay? Now, that's a quadratic equation. Whenever you solve a quadratic equation, what you're going to do is factor. So if I look at this guy, these numbers are pretty big. I'm noticing that I can factor out, right, a 10, right? So I'm going to divide this whole side by 10 and this side by 10, okay? So I'm going to pull that out. So now I'm going to be left with 0 equals x squared minus 3x minus 10, okay? Everybody gets divided by 10. And now this is way nicer, isn't it? Right? This is screaming to me that I should use IM. Okay, and it depends on the scenario, right? When we factor, this is IM, or some of you like to call it trinomial. Okay, and you'll see this on the homework. So we're going to multiply to negative 10 and add to negative 3. So that means I get x minus 5 and x plus 2. Okay, and when we did this during our review, okay, prior to going back to logs and exponents, you guys were good at this. This should be x equals 5 and x equals negative 2. Now, this kind of combines a lot of ideas that we've been working with, all right? So it is a little bit longer. Notice your homework is only 4 questions. What you have to do on the homework is you're going to have to check these, okay? So when I check x equals 5, what I'm checking to see is this number that's next to the log, when I evaluate it, it should not be negative, all right? So I'm going to go back to my original equation, right? So log 10, right? And I'm going to multiply by 5, plus, I'm going to use the original equation, log, and then 5 minus 3 equals 2. And I'm checking really on these numbers, okay? Are they negative? All right, they should not be negative. So then I get log of 50 plus log of 2 equals 2, if I did my math right. Now, is this a positive number? Yes. Is this a positive number? Yes. So then x equals 5 is not extraneous. It is a solution, all right? Now I'm going to do the same thing, a check with, notice I didn't go any further. I'm just making sure these are positive numbers. That's it. So x equals negative 2. Now I'm thinking I might have a problem since this is negative, but I don't know. It's not always true. You have to make sure you just check it. So I'm just going to simplify what I'm taking the log of. So what, 10 times negative 2 plus log of negative 2 minus 3 equals 2. And then I get log of negative 20 plus log of negative 5 equals 2. Well, these numbers inside, right, that parentheses, the log next to the log, these can't be negative. Neither, if one of them is negative, we're done, okay? It doesn't matter. They don't both have to be negative. If anything is negative here, then that means this is not a solution. The fancy word for that is it's extraneous, an extra solution. So that means x equals negative 2 is not an answer. So the only answer we have is x equals 5, and you can see I boxed that, all right? So you're going to have to check all your answers for 1, 2, 3, 4 problems for the homework, okay? Now, let's take a look at the next guy. So we have log base 4 of x plus 12 plus log base 4 of x equals 3. So it's a similar scenario, and you'll see this on your homework. So again, I'm going to follow my rules. So I'm going to condense first, okay? So this should be log base 4 of x plus 12, right, times x. So I'm going to multiply those two. I use parentheses. You could do it a different way, okay? But you want to show that they're being multiplied. Now I'm going to distribute that x inside. So I'm going to get x squared plus 12x equals 3, okay? So I distributed. Now my next step is I'm going to rewrite, okay? Make that a little bit clearer. Okay, I'm going to rewrite in exponential form, okay? So this is my base. So 4 to the 3rd power is x squared plus 12x. And then my log is no longer there, right? And I've freed up my x, okay? I've gotten rid of the log, so now I can get to that, all right? So now 4 to the third power. Well, what's 4 to the third power? 4 times 4 is 16. That's 64. Okay, then I'm going to get it equal to 0, so I'm going to subtract the 64. I'm not going to subtract the x squared and the 12x because I always want my x squared to be positive. Now, when you're trying to figure this out, you might want to use my trick, if you remember, okay, where we did y equals, on our calculator, 64 divided by x, and then if you go to the table, you'll have all the factors, okay? Or you can just guess and check using the factors of 64, because sometimes the numbers get kind of big. So 64, right, I believe is going to be 16 times 4. So 0 equals x plus 16, x minus 4, right? So 16 and a negative 4 add to positive 12, and they multiply to negative 64, right? Some of you like to use the dashes, right? So we're multiplying to 64, and we are adding to 12. So that should be 16 and negative 4, right? Those are the numbers that go into my parentheses. Then I set them equal to 0, so x is negative 16, and x is 4, okay? So those are my two solutions there. Then everybody's super excited. I can sense it. I can hear it, even though you're not here with me. Just kidding. X equals negative 16. We got to do our check in the original. So I'm going to go to log base 4 of negative 16 plus 12 plus log base 4 of negative 16 equals 3. Well, I don't even have to do the math here. Can I have log base 4 of negative 16? No, I cannot. So that means this is not a solution. It is extraneous. Okay, so one of my answers did not check, and that's okay. It might happen that both of them don't check, but don't worry, that doesn't happen on our homework, okay? Then, second check, right, which I think is going to be probably a good answer because it's already positive, but I have to check it, okay? So we have log base 4 of 4 plus 12 plus log base 4 of 4 equals 3. So this is good, right? This, right, and you don't have to really show me the addition. You just have to make sure you're doing the check. This is 16, so that's positive. This we know is already positive. I don't have to do anything besides that, okay? You don't have to do anything with the logs. Just, is this number that you're taking the log of positive? Is this number positive? Yes. So that means we have a good check here. So x equals 4 is a solution, and that checks, okay? So those are two examples. Use my steps, okay? I'm going to post these notes, okay? Use my steps. Keep in mind, on your homework for 49 and 50, they're a little bit easier, okay? When you go to do those are just using your 1-for-1 property, okay? Or equivalent log property, where you can just cancel the logs, all right, and solve. The big thing I want you to focus on here is the checks. 51 and 53 are more like these two, okay? So, like I said, give those a try. Please use my answer key if you need those to check. And then we're almost finished with logs and exponents, all right? I hope you guys are doing well, and I will hopefully see you soon.